Dear friends, Maths Aspirants is a collective of mathematics students, research scholars, faculty members, initiated by myself in 2017. And we used to organize several programs, those who are preparing for higher mathematics. Actually, we have started our platform as a discussion platform for those who wish to pursue higher mathematics and preparing for competitive examinations like CSER, NET, GATE, IIT JAM, etc. Now we have more than 6K members throughout our WhatsApp as well as Telegram and Google groups. Today we have a session on preparation strategies for IIT JAM 2026 exam. This is actually the first session of the IIT JAM lecture series. Today we blessed to have Miss Diya Saha. Miss Diya is a member of our group since her BSc days itself. I am very proud to introduce Miss Diya to all of you. Miss Diya did her MSc from IIT Bhubaneswar, and she cleared CSER NET with JRF with good rank as well as GATE examination, and she placed in TCS research and currently working as a research fellow at TCS research. So I'm sure that she will discuss her ideas about preparing IIT JAM examination. So I welcome everyone to this program, and I would like to express my sincere gratitude and thanks to Ms. Diya for being with Math Aspirants. I welcome everyone to this program. Welcome, Diya.
Thank you, sir, for this nice introduction. Actually, I am a member of this group, Maths Aspirants group from 2019, and as we all know, it was for COVID. That time, many schools and many colleges were not the regular program was not going well, so Maths Aspirants helped me to prepare for my competitive exams a lot that is. So thank you, sir, for this nice program. And it is an absolute honor to uh, have a chance to give this session about the preparation strategies of JAM. Actually, I will first start to talk about this IIT JAM examination. IIT JAM is actually a admission test for masters in many in IITs, IIScs, and ISERs. In many IITs and many IITs, they only consider the score of this exam as a admission criteria, but in IIScs and ISERs, they also they set a cutoff rank based on the your IIT JAM rank, and they conduct a interview after that. So this was IIT JAM, the website of IIT JAM 2025. Here you can see the many important dates if you follow these exams, and uh, JAM mostly follows the same calendar every year. So uh, as you can see that the application procedure starts on September, and the registration closes in mid-October. So, and the date of examination is February. Mostly the calendar remains same through for every year. Uh, in different years, different IITs took the responsibility to conduct this exam. And last year, I think IIT Delhi conducted it, and as you can see, their site is very well organized, and you can see the all the question papers and their corresponding answer keys here. This is the mathematics question paper. If you follow the link, the mathematics question paper is here, and it is the corresponding answer key. And here is the cutoff marks for different categories for MA exam. But here in IIT JAM, only clearing the cutoff does not ensure that you can get uh, admitted in your dream institute. Like we all have our expectation to join a certain institute, a certain IIT. So here you can check like this rank and merit list. So the rank and merit list is also available here. And if you can see that here the opening and closing ranks of round 1 is also available. So you can check the corresponding opening and closing ranks from here. Like if you choose, if you are choosing, say for example, IIT Gandhinagar, and you can see for all the opening and closing ranks for uh, all the rounds for mathematics for every category. And these are all ranks. So in my experience, if you are scoring in JAM, if you are scoring between 35 to 55, you can get a very good rank in JAM. So I will go there later. Uh, the previous year questions are also available here. Uh, So here they have provided all the previous year questions from 2012 to 2024, and it is very important to solve all the questions because it will give you an idea to what type of questions you can expect and what is the difficulty level of the questions. And they have provided one mock test link also. So if you follow this link, yes, here you can see the mock test link also. So when your preparation is complete, you can go to this link and take a mock test and familiarize yourself with the uh, exam module, or like that online. In we have to give our IIT JAM exam in online platform. So we have to, for if it is a MCQ question or MSQ question, we have to tick the correct options in online. If you have to, if it is a NAT question, you have to write the numerical values in the online. So it is very important to familiarize yourself with that setup. So yeah, I will go to the question pattern of IIT JAM. So IIT JAM is a 3 hours long exam, and the total marks is 100. So there are three sections. The question is divided into three sections. Section A is typically consists the MCQ questions. It means if four options are given for a question, only one option is correct. And there are 10 1 marks questions and 22 marks questions. So from this section you can score a maximum 50 marks, but be careful because section A, the questions of section A also consist of negative marks. So if you are if you get one question wrong, like if you are getting a question with marks 1 as wrong, then you will get a negative mark of -1/3. And if you are getting wrong marks 2 question as wrong, then you will get -2/3 as negative marks. So if you are getting like 3 questions wrong, so you will lose a lot of marks. So we have to be careful about this section A. And section B consists of multiple questions where multiple answers can be correct. So, for example, if you have four options for a question A, B, C, D, so all of them can be correct. Otherwise, A, B, C, or like 3 of them can be correct, 2 of them can be correct, even only 1 can be correct. So, we have to check option of this every option of this type of questions as if it is correct or wrong. But the good part is these questions does not have any negative marks, and each question carries 2 marks, so 20 you can score 20 up to 20 marks here. And part C is Iritty type question, so numerical answer type. It is almost like fill in the blanks as we used to do in our school days. So there also the questions are divided in 2 parts. 10 questions. There are 10 questions with 1 marks and 10 questions with 2 marks. So you can score up to 30 marks here, and there is no negative marks. So we have to be very careful while doing section B and C questions, because these sections does not have any negative marks, and we can score our maximum marks from these 2 sections. So here I will show the syllabus of this is the syllabus released by IIT Delhi for JAM 2025. So here we can see that they have divided the syllabus into 3 different parts. One is real analysis, and the second one is multivariate calculus and differential equations, and third one is linear algebra and abstract algebra. So the questions coming from linear algebra is very I feel that questions coming from linear algebra is like quite a bit easy compared to other questions. So if we practice these questions a bit, we can answer most of it in our exam. And the in every year if you follow the previous year questions of JAM, every year there are a lot of questions coming from real analysis and differential equations, and that question we can also answer those questions. And if we skip these parts, we are losing most of the questions of our exam. So my suggestion is, please do not skip this real analysis. So because it is a very, very important part of your exam. And obviously that group theory questions are also, you have to I mean, you have to do all of the syllabus, but I am just trying to point out the parts where you should focus a bit more, because these parts, uh, if you study the previous year questions, these parts are very important. I used to create like marks versus subject table in my for my exam. So if I can show you this, yeah. Yeah. So in our I gave JAM in 2021, and that time vector calculus is also a part of our syllabus, but now it is not. So you can ignore the this column, this row, vector calculus. But as you can see, for every year from real analysis you are getting 30 to 35 marks, and from linear algebra you are getting 15 to 18. So these parts are very important. Do you should prepare well for these uh, subjects. But I will suggest mm, not to skip a subject completely, because sometimes the examiners gave questions which are bit jumbled up from different subjects. Like it can be jumbled up from real analysis and differential equation. So if you skip differential equation completely, you can it can happen that uh, you have to skip a question which is very easy, and you are not getting that 2 or 1 mark that question carries. And 2 and 1 mark is a very big deal in this type of all India competitive exams. So these books I was used to follow for my jam preparation. Like for DL analysis, you can follow the book by S.K. Mappa. And for group theory, you can follow the book by J. Gallian. And linear algebra, you can, sorry, I think it will be Sheldon Exler. So you can follow your graduation books also. It is not necessary that you have to follow these books only, but uh, you should follow your one of the book that you can get the writing of the authors, and you can clear your basics from that book, and you can practice as many problems you like from different other books. And in maths aspirants group, Sir and Miss Amita, they share a lot of questions, and you should definitely solve them. And my suggestion is try to solve the gate questions or CSI and net questions also, because those questions, it may happen that those questions are not from JAM, but in JAM they can give similar type of questions. So as you solve many problems, your grip on those subjects will be better. So please do that. So I will try to discuss some of the questions from previous year, and get a feel like how the questions are. So most of my questions are from JAM 2025, and 2000, some are from 2021, 2017. This is a MCQ problem. Please try the problem, and let me know if you have any issue, or if you are able to solve the question, please share the answer in the comment section. And this is a hint. You can take this as a hint for to solve the question. So I I will give you a hint uh, the correct answer is B, but let's not focus on that. Let's try to focus on how to solve the problem. So, if we write the equation as mdx plus ndy equal to 0, so to be a exact differential equation, uh, it should follow this property that del m del y should be equal to del n del x. So, for us, if we look at the equation, n is given, and they have asked us to calculate n, and they have given us 4 different options for n. So our m is e to the power x sine y minus 2y sine x. Now, if we partially derivative m with respect to y, we will get e to the power x cos y minus 2 sine x. Because e to the power x is a function of x and sine x is also a function of x, so those remain as constant. Sine y is a function of y, so when we are derivating with respect to y, we will get cos y, and as y here we will get 2 sine x. So as the equation is given that the this equation is exact, so our del m del y should be equal to del n del x. So our del n del x is equal to e to the power x cos y minus 2 sine x. So if we integrate n with respect to x, then also we will consider cos y as a constant because we are integrating with respect to x. And integration of e to the power x will be e to the power x. And uh, if when we are integrating minus 2 sin x as minus 2 sin x with respect to x, we will get 2 cos x plus function of y. Because we are integrating n as with respect to x and function of y is a constant term. Now, if we match the options here, function of y is there is no function of y term. So we can also explain it from there, because if we again derivative n with respect to s with respect to x, then f dash y should uh, nah, if we so function of y, okay, if we uh, if we again derivative n as with respect to y, then f dash y should be 0, and we can, if we are matching here, then we will get that e to the power x cos y. So option B is correct, as we can see from here, because here f of y, if we match it, that f of y is not important. So, so our correct answer is B. Do any of you have any confusion? I can explain it again. Please let me know. Then I will go to the next problem. Okay, I will then go to the next problem. So please try it. Uh, then we can again discuss it as we did the before. This is a MCQ question. So only one option is correct. If any of you is able to solve the question, please share it. Please share the correct option in the comment section. So here they are asking the general solution of the differential equation. So we have to find the complementary function, and we have to find the particular solution of this differential equation. There are different ways to solve this problem. One method is the brute force method. You can pick one solution and you can try to fit it in the given equation, but I will suggest not to do that because it is a very time consuming process. Okay. Aisha is saying option A is correct. Let's wait few minutes for the others. So I will share one trick with you. Uh, First, we can first discard some of the options by checking uh, those criteria from options. So first, we have to check what is the Solution, answer is correct. The option answer A is correct. Okay. So our trick is first we have to check if uh, this this particular part is 0. So then what should be our answer? So if we take that d square y dx square minus 8 divided plus 16y is equal to 0, and we we write this auxiliary equation. So here we can see that 4 and 4 is the root of this equation. So our complementary function is alpha 1 e to the power x, alpha 2 x, sorry, alpha 2 x, it should be alpha 2 x e to the power 4x. My mistake, I have written x squared. So if we check the options here, so option C and option D are automatically getting cancelled, because here e to the power minus 4x is not the term of the complementary function. So here D cannot be our answer. So the remaining two options are A and B. So for that we have to find the yp. So we can write it as 1 by d minus 4 whole square 2 into e to the power 4x. Now e to the power 4, when we are writing in we are calculating the um, particular solution of solution, and the this term has e to the power x, and uh, we can uh, directly substitute put d with this coefficient of e to the power. But here we cannot do that, because here if we are substituting that, then we will get 0 here. But so we cannot do it here. So we write it as d plus 4 minus 4x, if um, d plus 4 minus 4 whole square. And so we were getting 2 into e to the power 4x, 1 by d square into 1. Uh, okay. So is my voice is okay now?
Yeah, yes, Diya.
Okay. So it is 2 into e to the power 4x into x square by 2, as 1 by if we sorry. So if we integrate 1 2 times, we will get x square by 2. So the final term is x square into e to the power 4x. So as we can see from here that our option A is correct, because for option B it is 2x square e to the power 4x. So option B is wrong. Option A is correct. So is the previous problem okay for all? Then I will go to the next question. Please let me know. Okay. So this is the next problem. Please try it, and we can again discuss it as we did for the first two. If any of you is able to solve the question, please share the options you are getting in the comment section. I will give you a hint. Please look into this part. And so, if you write it, write x n. If you replace n as 2, then you will get x3 equal to x2 plus 4. So for every n, xn plus 1 minus xn equal to 4. And then look into the denominator section of this expression. Everywhere it is like xn into xn plus 1. The n can vary, but it is like xn into xn plus 1. So try to rearrange these terms so you can use this hint. I will request everyone to try and solve it uh, alongside, because then it will get interesting, and you can also understand how the types of questions are coming in these all India exams, because this all the questions I am discussing, they have come in JAM 2025 till now. So if you are also solving the questions alongside the class, then it will be beneficial for you. So the correct answer is B, but let's not go into that. Uh, we will first try to solve the questions, that how it is going. So as I was saying that xn plus 1 equal to xn plus 4 for all n greater than 0. So for every xn plus 1 is always greater than xn for all n greater than 0. So we can say that xn is a monotonically increasing sequence. So as n tends to infinity, xn is also going to infinity. You can choose xn as any number, because you can choose xn as any number, but ultimately it will, as it is always getting added by 4, it is going to infinity. So, but one, as xn goes to infinity, 1 by xn will go to 0. Say for example, uh, if you consider the sequence 10 to the power n, so first term is uh, 10, the second term is 100, third time is 1000, fourth time is 10 to the power 4. So as n is going up, 10 to the power n is also going up. But if you consider 1 by 10 to the power n, then it is going to 0 because the first one is 1 by 10. Second one is 1 by 100. But third term is 1 by 10 cube. So 1 by 10 to the power n is going to 0. So this is an example. Uh, but there are methods to prove that if for n tends to infinity, if xn goes to infinity, 1 by xn goes to 0. But for the sake of our exam, we are not like we do not have to prove that this statement here, but you can check it using different examples and all. You can check it that this this statement is correct. So x3 minus x2 equal to 4. x4 minus x3 is equal to 4. Sorry, this is not 3. x5 minus x4 is again equal to 4. So we will use this idea in our to solve our problem. So this is our given statement, and we are taking 4 from here and we are multiplying it into the numerator. But we can x3 minus x2 is 4. So we instead of 4 we can write it here as x3 minus x2. x4 minus x3 is again 4, and our in the denominator it is x3 into x4. So we can write it here as x4 minus x3. xn plus 1, this is also equal to 4. So we are substituting this. Now, if we simplify it, we will get like this type of term. And this is getting cancelled. 1 by x3 is getting cancelled. 1 by x4 is getting cancelled. Similarly, 1 by x5 will getting cancelled. And this will go on, and only 1 by n plus 2 will be remaining. So in the next line, 1 by x2 is not getting cancelled, and 1 by n plus 2 is not getting cancelled from this equation. So this is our 6. Now, as 1 by xn is going to 0, 1 by xn plus 2 will also go to 0. So as n tends to infinity, our x2 will be 6 because this term is 0. Now x2 is 6. So, and we know this is true for all n greater than 0. For n equal to 1, this equation is true. So x2 is equal to x1 plus 4. And x1 is, if we substitute x2 as 6, x1 is 6 minus 4 equal to 2. So as we can see, our option B is correct because we are also getting x1 as 2. So is the problem is okay? Understood by all of you? We can explain again. Okay. So we can go to the next problem. If you are facing any issues, or if the problem is not understood, you can stop me and ask me about it. This is a problem from JAM 2025. Yes, I agree it is a Riemann integration, but let's not look into the problem like that. Let's try to find out what is the area of interval they are referring. So then your problem will be a bit easier. Uh, please try, and then we can discuss it again. Let's see. So here y-axis is from 0 to 1 and x is from root over y to 1. So I will suggest everyone to take a pen and paper and try to draw y-axis and x-axis and try to plot the area where which they are referring. This problem is uh, like the success of solving the problem is remains on finding out the area of integration. I have chosen this problem because I want to show you that we should not always try the problem like as it is given. We first we should try to look beyond the problem and like if an area of if an integration is given, we should first try to visualize the problem. First, we should try to visualize what is the area of integration is mentioning. Like then, like this trying to solve this problem is very hard. Like as it is, as the in the form they have given. But if you change some limit points, if you like extend something first, we integrate with respect to y instead of first integrating with respect to s, then the problem will get a lot easier. Uh, let's try it. The correct answer is A, but we will not look into that. Like as I was saying, first we will try to solve the problem as they have given. We will first we will first replace x cube as z, but then we can see that dz will be 3x squared dx, and our dx will be 1/3 z to the power 2 minus 2 by 3 dz. So if we replace it here, it is very hard to solve. So as I was suggesting, please try to visualize the area of integration. I have only drew a rough picture of it. So uh, uh, for us, what they have said, x is traveling from root y to 1. So I have drawn y equal to x squared, and we can say this point is root y, and it is going up to 1, and our y is going from 0 to 1. So y is going from 0 to 1, and so this is our area of integration. As if we plot it, we can see it is not necessary that we only do it like root from uh, we first covered the area of integration from by x-axis, then go like root y to 1, and then we go from for by y-axis like 0 to 1. We can go via x-axis first. Like we can go from x equal to 0 to y equal to 0 to x square this first, and then we can travel via x-axis, that 0 to 1. We will do that only in the next. So here, this is our given part, that x is x is going from root over y to 1, and y is going from 0 to 1. We are changing the limit. We are going from y equal to 0 to x square first, and x from 0 to 1. So why should we do that? What is the advantage? The advantage is, when we will try to integrate this, 3e to the power x cube is a function of x. It is not dependent of y. So we can treat it as a constant term and take it outside, and this will become x squared. So our term is 3x squared e to the power x cube dx. We can easily integrate it now, that it will become e to the power x cube, and the term is, and the limit is 1 to 0. So our very hard integration problem is uh, trans- transforming it a very easy problem if we choose to look into the problem in a different approach. If we first integrate it with respect to y, and then we integrate it with respect to x. So our I is e minus 1. If you put the upper limit here, I'm sure you will be able to do it. I will be e minus 1. So as we can see from the given option A is correct. So please let me know if any of you is having any problem. Then I can explain it again. Please let me know. First, look into the picture very carefully. So as we can see that, uh, like I was saying, if we try to solve the integral as they have given, it is very tough because then you will get one uh, z like z to the power minus 2 by 3 into e to the power z dz. And solving that particular equation is particular integral is not easy. So we are trying to solve the integral in a different way. And here the examiners are saying to first integrate the term 3x e to the power x cube with respect to x and then integrate with respect to y. We are we are trying to first integrate with respect to y, then integrate with respect to x. And we are changing, we have plotted our area of integration here, and we are changing the limits, upper limit and lower limits of the integral accordingly. Here, our x is going root over y. Here it is saying that x is going from root over y to 1. Now, if we take x equal to root over y, then we say that y equal should be x squared. So we are plotting that graph only, y equal to x squared. So uh, here we are seeing that first they are going from x equal to root over y to 1 and y from 0 to 1. And so this dotted area is our area of integration. Now, as we are trying to integrate with respect to y first, because our given function is not dependent of y. So, we are, mm, as we are integrating with respect to y first, the y limits of upper limit of lower limit will be y equal to 0 to x square and x equal to 0 to 1. This equation, this integral and this integral are indicating the same area of integration. Now we can solve the integral very easily. We we are taking 3 e to the power x cube as we are integrating with y with respect to y first. This is a function of x and we can take it outside, and if we integrating dy it is y, so it is x square minus 1, that is x squared. So 3x squared into e to the power x cube dx from x to 0 to 1. Now if we substitute z as x cube, then it will dz is 3x squared dx. So our integral is e to the power x cube from 1 to 0. So I is e minus 1. Uh, Please let me know if you are having any confusion anywhere. Okay. Okay. Then I will go to the next problem. If any of you having any confusion, please feel free to interrupt me and ask your doubt, or you can write it in the comment section if any of you have any doubt. So now we will try to solve some NAT problems. This particular question is from JAM 2017. In the NAT questions, you have to, like, they will give you this type of questions, and there will be given a box. You have, from using the virtual calculator, virtual keyboard, you have to first you have to solve the problem, and then you have to fill the correct answer in the box. Please write in the comment section if any of you is able to solve the question. We will discuss it again, but I will like if you I will like it if you try the question first. You can also discuss with us if any of you like that how you are trying, if how you are trying to approach the problem. So the correct answer is one, but we will first try to solve the question ourselves and see what we are getting as answer. Um, First, we are trying to write. Let's not Please not look into this theorem first. First, try to write n by Sn. Here, in this term, we have a term which is called n by Sn. So they have also given Sn and they have also given the term n. So first, we'll try to write what is n by Sn. So n is root n as given by our question, and Sn is a1, a2 plus n n. So n is root n. So a1 is 1, a2 is root 2, n is root n. I have written that only here. So now I am trying to rearrange it. I am multiplying 1 by, I am multiplying root n in the numerator and denominator. So that will be 1 by root n n by this term. But by Cauchy's first theorem, uh, if a sequence where n converges to a, then it implies that a1 plus a2 plus up to n by n is also converges to a. You can find this proof in any of the analysis book you are following. As I was saying, in 𝕐𝕬𝕐, they have given a very detailed proof. But I will not go to the proof section now. I will only focus to solving the problem. So our n is root n. So root n goes to infinity as n goes to infinity. We know that. So our n is going to infinity. So a1 plus a2 plus an by n, that is for our case 1 plus root 2 plus up to root n by n will also go to infinity. But this is invert 1 by this term. So this is going to 0. As we were discussing in the first or second question, that if for n tends to infinity, if xn goes to infinity, then 1 by xn goes to 0. As I was giving some examples that as n tends goes to infinity, 10, if we are considering xn as 10 to the power n, then 10 to the power n is also going to infinity. But 1 by 10 to the power n, if we consider 1 by 10 to the power n, that is going to 0. So you can consider many you can you can construct many examples and try to check if the statement I am making is true and false, true or false. But the statement is true, we can prove it by real analysis, but I am not going to do the real false. I will focus on solving the problem. So this term is going to 0, as our n by Sn is going to 0 as n tends to infinity. Now, they have not asked us that. They have asked us what is limit n tends to infinity n by Sn minus ln of 1 minus n by 1 minus n by Sn equal. What is the limit of this term? So we will try to find out that. First, we should simplify this term, this denominator term, that ln of 1 minus n by Sn. So we ln 1 plus x is x minus x square by 2 plus x cube by 3 minus dot dot dot. So this is if you know Taylor series, you can calculate it. No need to memorize it. But you should memorize some of these most common functions like ln 1 plus x. This you should memorize, because in the exam hall, if you are trying to solve every equation by yourself, then it will take a lot of time, and our time is only 3 hours, and we have to solve. At least we have to attempt all the questions. So I will suggest is please memorize some of the important problems, but uh, it is not like you have to do it actively. As you are like practicing many problems, it will come automatically. So our ln of 1 minus n by Sn, this is our term, right? The term they have given us in the question. So from this equation, we can get this. Like if we substitute x as minus n by Sn, we will get this equation. So we can simplify it, and this is the simplified term. Now here we have seen that n by Sn is going to 0 as n tends to infinity. So this term will go to 0, this term will go to 0, and all the other terms will go to 0. Only the 1 will remain. So our final answer is 1. Uh, Please let me know if the problem is clear, or if any of you have any doubt, please ask, ask the doubts. Thank you. So we can go to the next problem. This is also a native problem from JAM 2025. I will give you a hint. If you know the L'Hopital's rule, this problem should be easy to solve. Please try it and share your answers in the comment section. As I was saying earlier, in the in your exam also they will give this question like this only, and in the answer they will give a box and a virtual keyboard will be provided. You have to solve this problem, and like whatever you are getting as answer 2.1, 2.5, 3, 4, because uh, they have said right, it should be rounded up to two decimal places, so you should be very careful about that, because say for example you are getting a answer like 6.125, you should round it up to two decimal place and write that only like 6.13. Please don't write 6.125 as an answer, because we should follow the instructions the examiners has are providing. My suggestion is try to break off the two terms here. Like when I was solving the problem before making this slide, I did it like 1 minus cos x by some x to the power a. I first solved that problem, and then I focus on to the 2 to the power 2 plus x minus 4 by x to the power something that we should do. Now, uh, if we limit, we are trying to find the limit extends to 0 for this stuff. So if we put 0 in the numerator and denominator, we will get a 0 by 0 form. So by L'Hopital's rule, we can do the derivative of the numerator and denominator. No, sorry, Ivana, 0.56 is not the correct answer. Yeah, Aisha is saying 2. Let's wait for others. Then we can go to the discussion. No, ln 4 is not. Oh, okay, 2. Yeah, 2 is correct. The correct answer is 2. But in the JAM answer key, as I was saying that, because I am getting the correct answer 2, but in the JAM answer key, they have said they have given a range for the correct answer, like from 1.98 to 2.02. They are considering it as correct. So 2 is the correct answer. I will try to solve the problem. Those who have solved the problem, please let me know if you are doing it in any other way, so we can discuss and compare our methods. So we we know this postulate, right? Limit x tends to 0, sin x by x equal to 1. And our given term, we are assuming it as I, that is limit x tends to 0, 1 minus cos x, 2 to the power 2 plus x minus 4 by x cube. So as I was saying, it is 0 by 0 form, and I am splitting them, like limit x tends to 0, 1 minus cos x by x square, and limit x tends to 0, 2 to the power 2 plus x minus 4 by x. I will try to solve this one. Then I will look into this. So we simplify it. Cos x is equal to cos square x by 2 minus sin square x by 2. So this so we will get 1 minus cos x is 2 sin square x by 2. And in the denominator we have x. So here we can write it like this: sin x by 2 whole square into divided by 2 into x by 2 whole square. And if we take half as common, then sin x by 2 by x by 2 whole square. And as we know, limit x tends to 0, sin x by x goes to 1. So this term is going to 1. So our I becomes half into limit x tends to 0, 2 to the power 2 plus x minus 4 by x. So now we have to solve this term. So as I was saying, this is also in 0 by 0 form. So by L'Hopital's rule, we can do a derivative. And uh, so while we are differentiating the numerator, I am assuming z as 2 to the power 2 plus x. So if we are taking ln in the both sides, ln z is equal to 2 plus x into ln 2. And if then we are derivating 1 by z into dz dx is equal to ln 2. So dz dx is equal to 2 to the power 2 plus x into ln 2. So when differentiating this term, the numerator term becomes 2 to the power 2 plus x ln 2, and the denominator, the ddx of x becomes 1. So for x, as the denominator term is not 0, so if we put x tends to 0, as x tends to 0, if we put x equal to 0 here, then it becomes 2 square ln 2. Now we have, in the previous step, we got that I is half into limit x tends to 0, 2 to the power 2 plus x minus 4 by x. So I is half into 2 square ln 2, because this term is 2 square ln 2, and I becomes 2 ln 2. So if we compare it with alpha ln 2, our alpha becomes 2. So you guys are right. So alpha is 2. 2 is the correct answer. Please let me know if any of you are facing any problem or any doubts here, or you are using some different method to solve the problem. We can also discuss that. Okay, so let's go to the next problem. Okay, thanks, Ankit. Let's go to the next problem. Uh, this is also a NAT problem. This is a problem from linear algebra part. Previously, we are solving problems from real analysis, differential equations. So this is a problem from linear algebra. Please try to solve and share your answers with us in the comment section. Then we can discuss. My suggestion is if you have uh, studied the system of equations, please try to write these three. First, try to understand what is the meaning if a vector x y z w belongs to v1 intersection v2 intersection v3. Then try to find out what the properties that xyzw should hold. So in set theory, if x belongs to a intersection b, it means x belongs to set a also and x belongs to set b also. So x satisfies all the properties of set a and x also satisfies all the properties of set b. So if a vector belongs to v1 intersection v2 intersection v3, they should satisfy all the properties of v1, that is x plus y plus 2w. That is, first of all, that vector should be a element of R4, and they should satisfy the property that x plus y plus 2w is equal to 0. The vector, if as the vector belongs to the intersection of these three sets, uh, the vector should satisfy the property to y plus z plus w equal to 0, and the third, they should satisfy the third equation also. Okay, the Sneha is saying, yeah, system of linear equations, right? So what should be the answer? Like, what answer are you getting? Sneha is saying that the answer is 2. Yeah, correct, correct. I agree. Yeah, I also use the system of linear equations and the problem of augmented matrix. So both of you are correct. The answer is 2. Um, so as I was saying, that if xyzw belongs to v1 intersection v2 intersection v3, then x1 should the xyz should w should satisfy all the properties of v1, that x plus y plus 2w is 0. And if it belongs to v2, then it should satisfy all the properties of v2 to y plus z plus w is 0, x plus 3y plus z plus 3w is 0. And This is rank nullity theorem. This is one of the most important theorem in the in linear algebra, and in JAM, GATE, all the CSI net, all the all India exams, they give every year. They give at least one question from this theorem. So this is a very important theorem, and you should uh, positively practice as many problems possible from based on this theorem. So, as Ankit suggested, I will write it as a system of linear equations, and this is x plus y plus 2w is 0, 2y plus z plus w is 0, x plus 3y plus z plus 3w is 0, and then we try to it like a matrix. So this is our equations. We uh, if we do the matrix multiplication, we can go back to this term, this equation. So now we will look into the coefficient matrix. As in the rank nullity theorem, we can say that rank M plus nullity M is equal to Y, where Y is the number of columns of the matrix M. So we will first try. So we cannot find the nullity of M here directly because actually nullity of M is our answer, is our goal. Nullity of M is uh, the dimension of the kernel of this linear equation. Of this system. So we have to calculate the nullity of M. So we first have to calculate the rank of M. To calculate the rank of M, we first transform the matrix into the row echelon form. So to transform it into the row echelon form, we first do the row operations, because here 1 and 1 is in the same column. So if we do the R3 minus R1, we are getting this, and the second row and third row becomes equivalent. So if we do the R3 minus R2, we will get only the two non-zero rows in the row echelon form. So our rank of the matrix is 2. So this is 2, and our number of columns is 4. So nullity of M is 2. So they have asked the dimension of the subspace. Uh, what is the dimension of the subspace? So dimension of the subspace means this. What is the dimension of this? So yeah, as the nullity of M is 2, so we can say that dimension of this subspace is 2. If the problem is clear, we can go to the next problem. Please let me know in the comment section, or if any of you have any doubt, please also specify that. Okay. So I will go to the next problem. This is a MSQ problem. Here, multiple options can be correct. This is a problem from JAM 2021. So first, uh, write Ankit A and B. So let's wait some moments for others. See what others are saying. Then we can go to the discussion. First, my suggestion is first try to find out if G is even or odd. Uh, a even function means f of minus x is f of x for all x, and an odd function means f of minus x is equal to minus of f of x for all x. So Ankit is right. As we are approaching to the end of our time limit, I will explain it. So as I was saying, if is even, so in our assumption, first I was trying to see which option is correct between A and C. Now in both the options, they are assuming that f is even. So f of minus x is f of x. So g of y, as the given definition, g of y is supremum of x belongs to R, xy minus f of x. So we should find out what is g of minus y. If g of minus y is g of y, then it is even. If g of minus y is minus g of y, then it is odd. So as we can see, g of minus y is supremum of x belongs to R, minus xy minus f of x. Now, as we can see from here, f of x is minus f of minus x, and supremum of x is belongs to whole R. So uh, this will become g of f y again. Like if this is a supremum of x belongs to R, then for for x 0 to infinity, as it is the supremum, x for minus infinity to 0, this is also the supremum. So minus x does not like minus x does not give that much importance here, because this is the definition of our function g is the definition of our function g is like defined here. So g of y. So g is even. And so option A is correct. And for B and D, we have to check whether B is correct or D is correct. So for a given y, there exists a k belongs to R such that xy minus fx less than k for all x, because that is the formula, that is the definition, like g of y is supremum of x belongs to R. So if we change the sides, we will get f of x minus greater than xy minus kx minus k. And if we divide both of the sides by mod x, then as mod x tends to infinity as given by the option, so this part goes to 0, and f of x by mod x greater than y for any given y. So f of x by mod x goes to infinity. So I will. So is the explanation okay for all of you? Yes, Matthew. Thank you. I yeah. I will. I will look in. I will take that into consideration in the next session. Yeah, I agree that there are plenty of sources of solutions. How to think? Yeah, I was trying to do that, but I do not know how it is effective or not. Mm. But sometimes, like only giving ideas is not sufficient. We have to go to the solutions also. How to think the problem, like solving the problem, is the main motto of how to when you are solving a problem, you are getting the idea that how to think the problem. So please let me know if there is any doubt. Then I will go to the, if there is no doubt, I can go to the next problem. Okay. So this is the last problem in my slides, in my today's slides. Please try to solve. This is also a MSQ problem, and it is from JAM 2025. Okay, Ankit is saying that we can use Bernoulli equation. Uh, yeah, so what should be the answers, Ankit? Or can you explain your method in the comment? Or you can turn off your mic, I guess, and share with us your ideas.
Hello.
Yeah, hi.
Yes, ma'am. Uh, Good evening, ma'am.
Yeah, good evening, Ankit.
Both side divide is root में 2. Hello.
Sorry, there are a lot of disturbance from your end. Uh,
I am audible.
you are audible, but there are a lot of disturbance from your end. You can use the comments to write the like your ideas. As I was saying that you were saying that you can use the Bernoulli equation to solve the problem.
Hello, ma'am.
Yeah, hi. Ankit.
Ma'am, I use Bernoulli equation and root y both sides dividing and 1 by root equal to and both sides differentiation with respect to x and then use it.
Yeah, sorry, your voice got disturbed by lot of background noise. I will go to the solution. I think you were trying to say that we can divide both sides by root over y. Uh, so the correct answers are option A, B, and D. So uh, as Ankit was suggesting, that we can divide both sides by 1 by root over y. But I am I personally substitute z as root over y, and then this this is the like if we divide both sides by root over y, then this will be the resultant equations. And if we substitute z as root over y, then this will be our resultant equation. So if we calculate our integrating factor, then that will be e to the power minus integral e to the power x dx, and that will be e to the power minus e to the power x. And if we multiply both sides by e to the power minus e to the power x, then this side will become ddx of z e to the power minus e to the power x, and this side will be e to the power x minus e to the power x. And if we integrate both sides, then this side will be left hand side will be z e to the power minus e to the power x. And now if we substitute e to the power x as k and integrate it, then this will be the integral. And then we multiply both sides with e to the power minus e to the power x, then that will be z equal to minus 1 plus k e to the power x. Here k is constant. Now to find out the value of y, we have to find the value of k. To do that, we have some help, because here phi of 0 is given as 1. So if we put x equal to 0, then our k will be 2 by e, because this is 1. And so our y is 2 by e to the power x minus 1 whole square. So sorry. So if we take as x tends to ln 2, then this term will become e squared. So this is y equal to 2e minus 1 whole square. So option B is correct. Then C is false. And if we look into our solution function y, then we can see that it is an unbounded function, because for x tends to infinity, it goes to infinity, and for it is also a strictly increasing function on the interval 0 to infinity. Yeah. So the motivation behind this method, a very interesting question. So the motivation behind the method, like when I was looking into the problem, I was trying to see that if we can find like when uh, like in this type of problems you have to find the integrating factor. So to calculate the integrating factor, you can see that this like so when you can see the to calculate the integrating factor, you can see that this term I was trying to like make this function this right hand side devoid of any y term, if function of y term. So I divide both sides with 1 by root over y. So when I divide both sides with 1 by root over y, then I got this equation. So, but then I find out that if I substitute z as root over y, then our dz, my dz dx is this same problem. Sorry, this same term 1 by root over y dy dx. So I thought that if I substitute the whole equation uh, with respect to like if I substitute the whole equation, then my calculation of my integrating factor will be a bit easier. So that is the motivation. So that was my point. The more you solve this kind of problems, you will like you will be able to pick up these clues very efficiently. You can do these type of substitutions very fluently. Like I in the first second problem when I was discussing the area of integration, I I look into the problem and I got that, yeah, I have solved these kinds of problem earlier. So if I try to solve this problem straightforward, I will head into a lot of problem. Like I will get a z to the power minus 2 by 3 into e to the power z term. So that is not a very easy thing to solve. So my goal was, can I change the limits? Can I make the integration a bit easier? So that is the motivation that comes from the more you solve the problem, the more you can get this type of clues, this type of uh, hints you can pick up very easily. What is the quickest way to approach this kind of ODE? Right. So this kind of like this ODE problem is like as you can see from the question, like they are trying to find the solution. They are like no, like they are not actually trying to find the solution. They are asking you about different properties of the solution, like uh, what if it is an increasing function, if it is an unbounded function. But if you can look into the option B and C, you can get the idea that you have to solve the problem. So if you have to solve the problem, you can see that uh, you have to calculate the integrating factor first, because you cannot solve this problem directly. Like you cannot find like that y equal to e to the power mx and you can do that. You cannot do it like that. That is not possible. So you have to find the integrating factor. So your left hand side will become like some d dx into y into e to the power x, something like that. So you can find this is the role of the integrating factor. You It helps to like solve the OD. It helps to simplify the OD it can the integrating factor can transform your differential equation into an exact differential equation. So uh, there is no quickest way to approach. Like you have to find out these things. Like what is the goal of your question?
Okay, thank you, Diya, for this nice session. You have explained the details of the JAM examination, as well explained various types of questions like MCQs and MSQ, numerical answer type, through good examples taken from previous year question papers. I'm sure that those who have seriously attended the session will definitely get an idea about how to concentrate or how to charter their preparations in a right manner. Okay, yeah. Now it is the time for feedback or queries. Dear participants, feel free to share your feedback, or if you want to ask any doubt regarding exam or preparation, you can make it now. Feel free to turn on your video or mic and ask directly.
Hello,
Yes.
ma'am.
Yeah.
Hi.
Hello, ma'am. Is it audible?
Yeah. Hi.
Hi, ma'am. My name is Arya, and I am studying in St. Thomas College in Kerala. So, I want to share the feedback of your class. So it was a wonderful session, and we had solved many previous year questions in this session, and it was an informative session for all of us. I hope that. And I first of all take the opportunity to appreciate your effort that you had put in this class. And thanks for teaching us. It was a wonderful session. And thank you, ma'am, and thank you, Vinod sir, also for that. Thanks.
Thank you. Thank you, Arya.
Thank you, Arya.
Hear this.
Good evening, ma'am. I'm Ivana from Central University of Tamil Nadu. It was a nice class, and I got familiarized with the website. Even though I opened it, I never knew how to check the cutoff and all for each IITs. And you solved, like, you covered all the topics and all the types of questions. So thank you so much. Your explanations were very good. Thank you so much, ma'am, and thank you, Vinod, for also. Thank you.
Okay, thank you, Ivana.
Yeah, good evening, ma'am, and good evening, sir. The session was very nice and very explanative, and the problem was also very good, and last problem also very good, which asked me so many explanation in MSQ type. I want to ask some tips also regarding MSQ question, how to tackle them.
Sorry, can you repeat your question?
How to solve MSQ questions, and what things we should uh, focus, because these are very typical.
Okay, I think for MSQ questions, my suggestion is while you are before you start to solve the questions, please look into the options first, because in MSQ that is the most important criteria, that every option can be correct answer. So if you look into the options very carefully, you can take a hint, you can get a hint that what how to solve the problem. So you can, and like as I was saying for the last question, that when I was looking into the options from options B and C, I can see that they are are mostly focus on the solution part of the problem, and I have to solve the whole question, because uh, if I try to find that if it's what is that what should be the expression for x tends to ln 2, then I should have the whole expression of the solution to us first. But some questions, like for some questions, that is not necessary. Like if you look into the options A and B, they are mostly focused on the properties of the solution. So to find out the properties of the solution, it may not be like for this question we have to find out the solution, so we are doing that only. But in some questions it may not be necessary that we have to solve the whole question first. We can find out the properties of the solution from the question itself. So we do not so we can go for that also. And for MSQ questions, like same for the MCQ and the MSQ questions also, you have to solve many previous year's problems. So you can see that from which theorems or like which from which properties they are giving most questions. So you can solve those like properties there from that special cases of the theorems very carefully. Like it is very important for group theory to solve all the to know all the special cases and all the properties of a group. As in JAM, in GATE, they gave a lot of questions based on those properties. So my suggestion is to do as many questions possible.
Okay, thank you, ma'am. Thanks, sir.
Okay, thank you, Dharmendra.
Thank
And
you.
yeah, and there some of the participants have shared their feedback in the chat box as well.
Yeah, I was thinking.
Ayesh, Ayesh shared a,
Sir,
yeah, yes, Sangeet.
yes, sir, this time I railway station and
Uh-huh.
this
Yeah,
side more voice and not clear voice my, but today class is very helpful question and using thinking problem. Nice ma'am and nice sir. Thank you.
okay. Thank you, Ankit.
Thank you. Okay.
Yeah, Ayesha Siddiq commented, shared a lengthy feedback in the chat box. There, you can have a look at that. Okay. Any others who would like to share something? Please make it now. Otherwise, we can wind up the session now. Yes, Shabiba.
Hi, ma'am. Hi, sir.
Hi.
I'm Sabiba from Brahman College, Kerala. Um, I am now. I know this session for IIT JAM. I want to ask that will you prepare for any other entrance exam, or how you manage all those entrance exam with this IIT JAM?
Okay. Actually, in my graduation, that time they first allowed the like students with BSc degrees to write, or students with only BSc degrees to write the GATE exam. So I attempted for GATE also when I was writing the JAM, but mainly I prepared for JAM only. But I will I also read. I have also written the TIFR and ISI math exam. But my suggestion is like try to do all the previous year questions from different entrance exams. Like for you may not be focusing for TIFR. Say for example, you may not be focusing for TIFR, but in TIFR they give the questions like they prepared the questions of a they prepare a very good sort of questions, and the questions come. You can only solve the questions if you have a very good understanding of the topics. So while you are solving the problems, many of your confusions got cleared. Like so, say you are solving some real analysis problem from TIFR, like true and false problem. So you have to go back. If you are not able to solve the problem, you can go back to your basics and you can clear all the uh, where you are getting stuck, and you can solve the exercises of your graduation books. So those things help. Uh, so my suggestion is sure you should focus uh, if you are preparing for JAM, you should focus on JAM, but do not constrain yourself only for one entrance exam. Try to do as much problem possible, because sometimes they may not give you the same problem, but they can give you the same type of problems, problems coming from same theorems. Like I was saying that many questions come every year in all the exams for rank from the rank nullity theorem. So you should try to solve them.
Yeah, let me add one point from my side too. Yeah, compared to other entrance exams, Diya, you are muted, I think.
Yes, sir.
Hello?
Hello. Yes, sir. Am I audible?
Yeah, it just coming. Okay. Are you saying something?
No, sir. You were saying that.
Okay, okay. Yeah, I'm telling that compared to other exams like TIFR or ISI or CMI, JAM is comparatively more easy to clear. And also another advantage is that for getting admission in IIT or NIT based on the JAM, there is no interview or anything like that. But for TIFR, if you qualify the written, then still you have to pass in the interview also. So for the students, JAM is the most easy thing to get.
Yes, sir. I completely agree, because in IITs they do not
Yeah,
take any interview and all.
yeah.
So it is comparatively easier to get.
Yeah, if you want to get admission in ISOs or IISc based on the JAM score, then you may have to face the interview. But for IIT and NIT, it is too easy because only the score is needed.
Yes.
Okay, thank you, Diya, for this nice session, and thank you for being with Math Aspirants. And I take this opportunity to wish all the success in your academic and professional career. All the very best, Diya.
Thank you, sir. It's a great honor to have an opportunity to present this session.
Okay, thank you, everyone. Let us wind up here. Bye. Good night.